In this video, I'm going to be introducing some common parameterizations. Now, I cannot emphasize this enough as I work through this video, so I'm going to emphasize it big and bold right away. Parameterizations are not unique. Parameterizations are not unique. What I'm going to give you in this video are common parameterizations, but that does not mean that this is the only way to do these things. There are lots of different ways. In fact, I would dare say that most things that can be parameterized can be done so in an infinite number of different ways. So again, these are common parameterizations, not necessarily unique. So first one is anytime we have y as a function of x with a certain domain associated with x. Very common parameterization to do in this case would be to simply allow x to be equal to t, and then plug that in and allow y to be f of t. Then you can simply say that t is going to go from a to b. So as an example of this kind of thing, suppose that we have f of x is equal to x squared minus 1. Then a really common parameterization would be x is equal to t. And if we plug in x is equal to t, then we'll get y is equal to t squared minus 1. Is this the only way to parameterize it? Not necessarily, but it is a way to parameterize it. Similarly, if we have that x is a function of y, which we have seen a couple times, with y going from a to b, then a very common parameterization is to allow y to be equal to t and allow x to be that function of t, g of t. Then you can say that t will range from a to b. So for example, if you had x is equal to the sine of y, and then y goes from negative pi over 2 to pi over 2. Something that you might consider setting up when talking about inverse trigonometric functions. We could say that y is equal to t, that x is equal to the sine of t, and that t is going to go from negative pi over 2 to pi over 2. However, we could also set it up as x is equal to t, y is equal to the arcsine of t, and then allow t to go from negative 1 to positive 1. It's not necessarily unique. Now, this next one is one that comes up a lot in Calc 3, so we're going to talk about it today. This is going to be the line segment connecting the ordered pair x1, y1 to the ordered pair x2, y2. The reason this comes up a lot in Calc 3 is because we extend this into 3 dimensions, and we'll be doing x1, y1, z1 to x2, y2, z2. Parametrically is one of the ways that we define what lines are in 3 dimensions. Now with that in mind, I'd like to get an appropriate mindset going on for this, which is that point slope form of a line, y minus y1, is equal to m times x minus x1. This is where y is taking on the role of the dependent variable and x is taking on the role of the independent variable, and this is where m is equal to a change in y over a change in x, or most typically you'll see that as y2 minus y1 over x2 minus x1. What we're going to do is we're going to do exactly this mindset, but we're going to do it twice. We're going to do it once with x as the dependent variable and once with y as the dependent variable, and in both cases t is going to be the independent variable. So with that in mind, I need to associate a value of t with both of these, and this is where the parameterization is not necessarily unique thing comes from. So we'll say t is equal to t1 will be associated with x1, y1, and t is equal to t2 will be associated with x2, y2. I need more space. Hey look, more space. So here's the mentality that we're going to get into. We're going to say that x minus x1 is going to be equal to m. So the change in x, x2 minus x1, over the change in t, t2 minus t1, times t minus t1. Yeah, that looks great. So with that in mind, we can also say then that x is equal to x1 plus x2 minus x1 over t2 minus t1 times t minus t1. That would be a good parameterization for x. Now if we do the same thing for our y variable, we can say y minus y1 is equal to the slope, which will be the change in y, over the change in t, times t minus t1. Or, once we actually solve this for y, we can say y is equal to y1 plus y2 minus y1 over t2 minus t1 times t minus t1. Minus. And that should be a set of parentheses. Then we can specify that this is going to be that t ranges from t1 to t2. There is a way to make this so much simpler. The way that we can make this so much simpler is let t1 be 0 and let t2 be 1. So this is the general form, and now I'm going to write down the recommended form. The recommended form is going to be x is equal to x1 plus t2 minus t1 is now officially 1 minus 0. Division by 1 minus 0 is division by 1. So this will be x2 minus x1 times t minus t1, but t1 is now 0, so this will just be t. A way that we like to shorten this up is we can say that x is equal to x1 plus delta x times t, just whatever the change in x is. If we do the same thing for our y variable, this will be y is equal to y1 plus, same sort of thing here, t2 minus t1 is now 1 minus 0. So y2 minus y1 divided by 1 doesn't have to be written over 1 anymore. Then t minus t1, that's just going to be t minus 0, so times t. Or more commonly, y is equal to y1 plus the change in y times t. And again, this is operating under the assumption that t is going to go from 0 to 1. Let's do one quick example of this. I would like to connect the ordered pair negative 2, 4 to the ordered pair, let's do 3, negative 7. So with that in mind, I'll be labeling this as x1, y1 and x2, y2. Rather than going t1 and t2, this time I'm just going to go straight to, this will be t equals 0, and this will be t equals 1, so I can use these parameterizations right over here. So we just said x is equal to x1 plus the change in x times t. Well, x1 in this case would be negative 2 plus the change in x would be x2 minus x1, or 3 minus negative 2. 3 minus negative 2 times t. So this will be negative 2 plus 5t. You can verify for yourself that when we plug in x equals 0, we're going to get negative 2. And when we plug in when we plug in t equals 0, we'll get x equals negative 2. And when we plug in t equals 1, we'll get x is equal to positive 3, which is exactly what we want. Repeating this process for y, y is equal to y1 plus the change in y times t. y1 is 4. Change in y is going to be negative 7 minus 4 times t, which will be 4 minus 11t. Once again, we verify. Plugging in t equals 0 is going to give us y equals 4, and plugging in t equals 1 will give us y equals negative 7. Then we throw on that t goes from 0 to 1, and we're good. I have more parameterizations, but this video is already too long, so we'll save it for the next one.